Yesterday we talked about inverses, right? 1-6, we talked about how to find them from a graph, how to find them from an equation, how to find them from points, and then how to find them directly from the equation where you're actually finding the new equation. So to identify if something has an inverse, it's the same thing as saying, is it 1-to-1? So remember, those mean the same thing because they can be interchangeable. So is number 1 1-to-1? This would fail your horizontal line test, right? It's a function, but it's not 1-to-1. So it doesn't have an inverse. How about 2? Does that have an inverse? No, it would also fail your horizontal line test. How about 3? Yes, 3 would have an inverse. It would pass your vertical and your horizontal line test, okay? And then 4 says f of x equals x squared, or x to the 6 plus 3. So when is it no based on the equation? X is raised to even or good, or x is an absolute value. So does 4 have an inverse? No. Does 5? Yes. And then 6 is find the inverse of the function. So the first thing we're going to do is rewrite it with y in place of the f of x. Then what's the next step? Switch the x and the y. Then I'm going to solve for that new y. So x minus 5 equals 2y. And then divide both parts by 2. And I get y equals x over 2 minus 5 halves. And then the last step, which you're not going to forget to do because you'll lose points, is replace the y with your f negative 1 of x. Because it is no longer that same equation. We changed it, which is why you can't leave it as y.
So we can't leave it like all over 1?
Like x minus 5, you mean over 2?
Yeah, over 2.
Yeah, that's fine. X minus 5 over 2. Yeah, and WebAssign would have taken either answer. Just be careful. Like a couple of things I'm seeing on WebAssign is, remember that you can't use the actual letter X like on your keyboard. It shows up as like a capital X, but it will mark it wrong. You need to use the variable X. And then again, like don't stress about the graphing portion. I know you want to see the right answer, which is good for you. The green check is validating. But remember that I'm never going to give you a test on WebAssign. So I would prefer that you make sure you know how to graph it by hand. And if you're getting frustrated or if marking wrong by the graphs, don't stress out about it, okay? Any questions on the homework from last night? Remember again that after 8 a.m. you can go back in and you can see your correct answers. You want to be making a habit of that so that you can make sure that if you got it wrong, you understand why you got it wrong. Okay, the point of homework is to obviously practice it, but it's also to learn from mistakes. Everybody's good? All right, so we're going to start 2-1 today. It is a beast of a section. I think there's like 19 slides on this thing. It's like everything you ever thought you didn't want to know about a quadratic function. A lot of this stuff you already know, so we're going to kind of review it. It just takes it a little bit more in depth. So we are no longer approximating what these graphs look like. We are getting very specific on points and that kind of stuff. So quadratics are your parabolas, right? The graph of f of x equals ax squared plus bx plus c. This is called quadratic form. The shape is called a parabola. It's obviously shaped like a U. You know that. And it's symmetric to a line called the axis of symmetry. So the axis of symmetry is going to be a vertical line that runs through your vertex where it is reflected over it. So the right side of that would be symmetric to the left side. All right, so what does the parabola look like and what are these parts, right? So that, again, this is in quadratic form, okay? You've got your parabola, whether it's pointing down or it's pointing up, okay? The axis of symmetry is this vertical line that runs through the through the vertex. The vertex is that point in which your graph changes from increasing to decreasing or decreasing to increasing. So all the things we talked about before, max and min, increasing, decreasing, domain and range, all that stuff gets carried over. The differences with these are absolute maxes and absolute mins. You will only have one of them. So you can't have multiple or relative max or relative min. You'll only have one. If it's upward facing, obviously it's minimum. If it's downward, it's a maximum. Those coordinate points, depending on how they ask you for it, the coordinate point's the max or the actual value of the y is. So it depends on how it asks for it, which I'll talk about when we get there. If a is greater than 0, if my x squared is positive, then my parabola opens upward. If A is less than 0, then the parabola opens downward. So remember, A is whatever's in front of the x squared. Positive, it opens upward. Negative, it opens downward. So this equation is actually in standard form. Standard form is what we know based on our, is what we used for our okay, standard form. Notice that the x itself is not squared. It's in parentheses squared. Okay, so that's the difference between quadratic and standard. Standard form is what we use our transformations for. So what do I know about this specific graph based on its transformations? 1 to the left.
2 times faster.
And then it's going to grow faster, right? Or be narrow or stretched, anything like that. Now the difference between where we were before and where we're at now is you need to plot some points this time. So the vertex I can get from just shifting it. So I'm going to 1 unit to the left. And then I know that my graph is going to look something like this, but I need exact points here. So what you can do is just plug in a point to the left of your vertex and a point to the right of your vertex. So if my vertex is at -1, then one left of it would be -2, and past there, -3. And then to the right of it would be 0 and 1. So we're going to just plug in those points. So I plug in -2 in here, 2, -2 plus 1 squared, 2, -1 squared, 2 times 1, which is 2. Then I'm going to plug in -3, 2, -3 plus 1 squared, 2, -2 squared, 2 times 4, which is 8. And then 2, 0 plus 1 squared, which is 2 times 1 squared, 2 times 1, which is 2, and 2, 1 plus 1 squared, 2 times 2 squared, 2 times 4, which is 8. So I go from my approximation to my precise graph by doing -2, 2, 0, 2, -3, 8, and 1, 8. So what do you see about the points to the right and the left of this graph? They're symmetric, okay? Which means you can save yourself some time on plotting points, but it also means if you have the time, you want to plot those points to confirm the other one. So if you did the math wrong on the first one, you can use the second one to catch it, okay? If you're always doing left and right of your vertex, they should be symmetric. Questions on that one? Yep.
So you can just how many points would we have to find?
You probably won't have something just like this. You're going to be able to use, I would say you need at least 3 points, but you're going to be able to use things like your intercepts and that kind of stuff eventually to help you with it.
Okay.
So if you weren't 100% sure, you can always put more.
And then you can always just find one and then use the axis.
Yeah, I just would be really careful because the good point of finding the other one is that you can catch a mistake. So if they don't match. But yes, you can symmetry to find the other one. Okay, so functions in standard form. So we just said this. This is standard form. F of x equals a times x minus h squared plus k. This is what we're used to with our transformations. From here, your vertex is hk. So the opposite of what follows the x inside the parentheses. And then whatever your vertical shift is would be your y. And then your line of symmetry is always an x equals. And again, it's something people mess up a lot. It has to be a line, which means it has to be an equation. And it has to be an x equals. And then it always equals the x coordinate of your vertex. So just by looking at the equation, you can find that information before you even need to graph it. To graph using standard form, so here's the approach I would say you could take. Determine if the parabola opens upward and downward. Find the vertex. Find any intercepts, because you're probably going to be asked for those anyways. For the x-intercept, you're plugging 0 in for y. For the y-intercept, you're plugging 0 in for x. Plot the intercepts, the vertex, and then any additional points if you need it. So if my x-intercepts are only, if I don't have any x-intercepts, right, then it's not enough points to just have the vertex. If I have a y-intercept and 2 x-intercepts, then you're probably good to go. You don't need any extra points. So I would say you need at least 3 points but you need them to be vertex, right of the vertex, left of the vertex. If you have an x-intercept and a y-intercept, but it's all just to the left, you still need another point on the right-hand side to balance it out.
You want to go back to the last.
All right, so it says graph the quadratic function. F of x equals negative x plus 2 squared plus 4. So just from the initial part, what do we know about this graph? It points downward, okay? What do I know about the vertex? Negative 2, 4. Opposite of what follows the x, and then whatever is the k by itself. What's my axis of symmetry? Good. X equals negative 2. So already I have this information. I have negative 2, 4 is my vertex. I know, again, I can approximate it. It's going to point down. And I've got an axis of symmetry. X equals negative 2. Now I'm going to figure out what my intercepts are because, again, it's probably going to ask for it, so you might as well find them. So my x-intercepts, I'm going to set y, which is f of x. Plug 0 in for that. Negative x plus 2 squared plus 4. So then I'm going to subtract 4 from both sides. Divide or multiply by negative 1. Square root, but when I square root, what do I have to make sure I do? Plus and minus on the other side, right? So x plus 2 equals plus and minus the square root of 4, which is 2. And then subtract the 2. So I have two answers here. Negative 2 plus 2, negative 2 minus 2. Or 0 and negative 4. So now I already have more information. I can plot these points. 0, 0, negative 4, 0, which confirms my symmetry. What's going to happen to my y-intercept? Do I know it already? 0, 0, yes. But let's go through the motions because it's not always going to happen that way. I'm going to plug in 0 for x. So y equals negative 0 plus 2 squared plus 4. I get y equals negative 2 squared plus 4. Y equals the opposite of 2 squared. So negative 4 plus 4, which is 0. So I already have that point. So again, if you have your vertex and you have a point on the left of the vertex and the right of the vertex, you have enough information to plot your parabola, you're good to go. So I'm just going to draw these. If for some reason you only have one of those or you have none from your intercepts, because really you could have like one y-intercept and no x-intercepts, then you have to plot additional points. But if you get enough information based on your intercepts, then you can go from there. Questions? Okay, you do it. All right, so you should have gotten vertex 3, negative 4, axis symmetry is x equals 3. your x-intercepts are 5 and 1, and your your y-intercept is 5. So if I plot all that information, I had my vertex, I've got my x-intercepts 1 and 5, and then my y-intercept is at 5. I know some people like can't handle the balance, the non-balanced points there. If you wanted to plot that point as well, it's totally fine. So you went left 1 and up 5, you would go right 1 and up 5 to get that same point. You don't need it though. As long as you've got the 3 points, again, including the vertex, 1 to the left, 1 to the right, then you're good to go. Questions on that one? So I do want to stress one thing, and that it's that both of these examples had a perfect square when we went to go square root it. So if from here, let's say, this said 3 equals x minus 3 squared, and then you went to square root both sides of the equation, I'd have a plus and minus here, but I'd get x minus 3 equals plus and minus the square root of 3. And then I go to add the 3, and there's two answers here, 3 plus root 3 and 3 minus root 3. So when the quiz or test asks for your intercepts, you're going to write it like that. You're not going to round that. You're going to keep it the way it is. You'll keep it exact. When you go to graph it, that's when you're going to approximate it. So if I'm using those points to graph, then I'm going to say square root 3 is in between square root 1 and square root 4, closer to 4, so maybe this is like a 1.8. So then I do 3 plus 1.8, which is 4.8, again approximating just to plot my point, and then 3 minus 1.8, which is 1.2. So only if they're not perfect squares, you have to worry about it, but you probably will get ones that are not perfect squares. When you go to square root it, you will leave it as a simplified square root to give the answer of the intercepts, but when you go to graph it, you're going to have to approximate. Questions? All right, now how do we put something into standard form if it's not? So I don't know if you remember a little thing called completing the square, but you're going to use it several times this year. So we'll review it today. We're going to come back to it again like twice, maybe 3 times this year. Okay? But if my equation is not in standard form, then one of my options is to force it into standard form by completing the square. So for completing the square, these are your steps. You're going to group A, X, and B together. So you'll end up putting parentheses around these. First of all, it has to be in order from left to right. Then you're going to group AX squared and BX together. AX squared and BX together. If A is not 1, meaning that there's a number or even a sign on X squared, you have to factor it out. So you're going to take it outside of the parentheses. When you take it out of the parentheses, it's coming off both the X squared and the X value. So you're going to divide this by A, you're going to divide that by A. Both of them are going to get, and then the A would go to the outside, and you'd get X squared by whatever was divided by, and then BX by the A. And then C is still to the outside, so you're still bumping out C. Then you have to complete this square. So you have to find the last term on that trinomial that would make this a perfect square. And to do that, you take B, divide it by 2, and square it. You're going to add that inside the parentheses, and you're going to subtract it outside the parentheses to balance your equation. Then you're going to factor it. So even before you get to the final thing, you're going to factor your new perfect square trinomial. Whatever the result of because you're forcing it into a perfect square, you're going to factor it by square rooting the first term. So there's a shortcut. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses and square it. So what you're doing is taking something that is not a perfect square trinomial, forcing it to become a perfect square trinomial, factoring it, and then you've put it into standard form. Obviously, we're going to work through an example on this. But complete the square is one of those skills. Hopefully you remember from last year. And if not, iTunes U course is a video on complete the square with examples on complete the square. Because there's not a separate section in the book for just complete the square. All right, so this says, write the function in standard form, identify the vertex, axis of symmetry, and x-intercepts, and then graph. So I'm going to start by completing the square. I group together the first 2 terms, x squared minus 14x, and then the plus 54 stays to the outside. Now, is there something in front of the x squared? No, we're going to baby step our way into it, right? So we don't have to factor anything out, which means I am going to skip right to the step, minus, where I find the part to fill in at the end of that parentheses. So to do that, I take 14, I divide it by 2, and then I square it. 14 divided by 2 is 7. 7 squared is 49. I'm adding that inside the parentheses and subtracting it outside the parentheses. Because I have to balance that side of the equation. I can't just add something without balancing it out. With me so far? So what we've just done is make that a perfect square trinomial. So now I'm going to square root the first term. The square root of x squared is x. Square root the last term. The square root of 49 is 7. Take the sign from the middle term, which is negative. Put it in parentheses and square it. So I just factored it. And then I'm going to combine these terms together. 54 minus 49 is positive 5. With me so far? Okay, now it's in standard form. So now I can go back to where I was before. What's the vertex on this function? 7, 5. What's the axis of symmetry? Good. X equals 7. Is this parabola opening upward or downward? Upward. Okay, so already I have that. 7, 5. And it's going to open upward. Okay. It said to find the x-intercept, so I'm going to plug 0 in for y. And you can plug it in up here, or you can plug it in here. It doesn't matter which one. 0 equals x minus 7 squared plus 5. Subtract the 5. Square root both sides. What happens when I try to square root negative 5? It's an imaginary number, which means no x-intercepts. If we look on what we just approximated, the graph, that makes perfect sense. That's a parabola that's all the way over there pointing up. It's never going to cross the x-axis. Which means I have to do what to get it to graph? Plot additional points. So I'm going to go left of my vertex and right of my vertex. The x on the vertex was 7, so I'm going to go 6, and I'm going to go 8. 6 minus 7 squared plus 5 is negative 1 squared plus 5, 1 plus 5, which is 6. And 8 minus 7 squared plus 5 is 1 squared plus 5, 1 plus 5, which again should be the same, so it makes sense that it's 6. Now I have my graph. Questions so far? Now it didn't ask for it, but if it had asked from the y-intercept and my equation started in quadratic and I force it into standard form, the y-intercept is always easier to find from quadratic form because I plug in a 0 here, it's gone. I plug in a 0 here, it's gone. And then my y is the only thing that's left by itself. So my y-intercept would be 0, 54. It's always easier to find your y-intercept if it's in quadratic form. X-intercept, if it's not factorable, which this one wouldn't have been factorable, it's easier to find it in standard form. Otherwise, you have to use the quadratic formula. Questions on that one? All right. Your other option is to keep it in quadratic and graph it. So you will be, on your quiz and on your test, you will be forced to put it into into standard by completing the square. But then you'll also have the option where I just give you an equation and you choose how you want to graph it. And that this is the other option. You can keep it in quadratic form, which is ax squared plus bx plus c, and then find the vertex by finding the h as negative b over 2a, and then plug h back in to get k. So negative b over 2a gives you the h, and then you can take that, plug it back into your equation to get whatever k is. axis symmetry is still x equals h. You would still find your intercepts the same way, and then you'd graph using the vertex and the intercepts or additional points if there's no intercepts. So again, you're going to be forced to use to complete the square to get it into standard form for a question. But then I could give you another question that's in quadratic form like this, and you could choose. Do I want to force it in to complete the square? And honestly, I would avoid it if there's a number on the front, because we'll work through an example like that, but that obviously makes it a little bit harder. Or keep it this way. So this says find the vertex of the function f of x equals negative x squared minus 3x plus 7. So we're going to work through it the way we just said. My vertex is negative b over 2a for the h coordinate. So a is negative 1. B is negative 3. My vertex, the h coordinate of my vertex would be negative 3 over 2 times negative 1. And I'd get 3 over negative 2. So the x coordinate of my vertex is negative 3 halves. Then I'm going to take that and plug it back in. So y equals negative 3 halves squared minus 3 times negative 3 halves plus 7. Notice I plugged it in parentheses because I'm going to square it first, and then that negative is going to go on the front. Why don't you write some of this down? So I get negative 9/4 plus 9 halves plus 7 equals y. And yes, you're back to dealing with fractions. So you can either change them to all have the same denominator. If your a is greater than 0, which means it's positive, then your parabola is going to open upward, and you're going to have a minimum value. The minimum is just the k coordinate, so just the y coordinate of your vertex, because these are absolute max and mins. If it's less than 0, it's negative. It's going to open downward, and you have a max. Again, that point is just the k or the y coordinate of your vertex. So if you look back on the example that we just worked out, you can say that this graph would open downwards because it's negative, which means it's got a max value, and the max value is the k or the y coordinate of your vertex, which would be 37/4.